in this video I'm going to just do the next one on page 213. So in this one we have a coach selecting some players trying out for the varsity team, and then the rest are going to be on the junior varsity team. So basically it's just two different groups, the varsity and the junior varsity. Okay, and there are 8 players trying out. So here are options, or players. 8 of them. If N or Q is selected for varsity, R will not be. So if N is on varsity or Q is on varsity, then Rachel won't be on varsity. If Rachel's on varsity, then N isn't and Q isn't. Okay, so we negate every part of that, including the or, which changes to an and to make our contrapositive. Okay. Either S or W, but not both, will be selected for junior. So one or the other one is going to be out. If we have A or B, but not both, essentially it just means one of them is in and the other one is out. So this is a biconditional where they always have to be separated. So I would actually just do that. That's how I would represent that one. Okay, so A or B, not both, means the same as that. One is in and the other is out. Okay. S and R will be selected for the same team. Okay, so S and R are going to be together, so I can even add them together here. Okay. If Nick is selected for junior, then Otis will be 2. So if N is not on varsity, because that's what junior means, right? Junior is just the same as not on varsity. So if Nick is on junior, which means not on varsity, then Otis will be on junior 2. So if Otis is on varsity, then Nick is on varsity. And this doesn't mean that they always have to be together. It is possible that Otis isn't picked and that Nick is. So if Nick is selected for varsity, then we don't know what happens to Otis. And if Otis isn't selected for varsity, we don't know what happens to Nick. And then this last rule, if Tim is on junior, then Wilma's on varsity. So if Tim isn't on varsity, then Wilma is on varsity. If Wilma's not on varsity, then Tim is on varsity. And this doesn't mean that they can never be together. They could be together if both of them are on varsity. So if Tim's on junior varsity, so not on like varsity, right? Not on varsity, then Wilma will be on varsity, and the contrapositive is true as well, right? So if Wilma's on junior, then Tim is on varsity. But it's possible they could both be on varsity because that wouldn't trigger that rule. So the way I like to look at it is like both of these things could happen at the same time. Both of these things could happen at the same time. Like that's a possibility. So yeah, but if we trigger the rule, then we have to follow the consequence. So yeah, but the triggers are always on the left side. Okay, so and triggering it just means that that thing is true, right? That the thing on the left side is true. So triggering this rule would mean either that N is not on varsity or that O is on varsity. So those are the triggers that make the rule work. Okay, so that's the setup for this guy. In terms of answering, if O is selected for varsity, then that's going to trigger this rule here. So then that means that N is going to be on varsity as well. So O and N would both be on varsity. Okay, N being on varsity means that R is not on varsity. And since R is not on varsity, S is also not on varsity, and then W would be on varsity. W being on varsity doesn't trigger anything though. Okay, so these are the things that we would know to be true for 1. So what could be false? Could it be false that N is selected for varsity? No, that has to be true. W for varsity has to be true. Rachel for junior has to be true. Sarah for junior has to be true. But Tim could be selected for junior, right? So it's possible Tim is over here and not selected for varsity. That is possible that that's true, but it's also possible that it's false. So Tim could be selected for varsity, because W being selected for varsity doesn't mean for sure that Tim is on junior. W being selected for varsity isn't a trigger, so this rule doesn't apply in this case. Okay? So this rule is no longer relevant, which is why E is possible. All the other ones were triggered because something on the left side was true, right? So one of the sufficient conditions was met. But this rule wasn't triggered. Okay. We also don't know where Q is, so they could have said something about Q, and we don't know anything about Q at this point, but they didn't. I'm trying to think if there's any other player that's not mentioned, but yeah, all the rest of them are actually mentioned. Quite a few rules with this one, quite a few players involved. Okay, so that's question 1. Question 1 is E. Question 2. Which one of the following can be a pair of players, both of whom are selected for varsity? Okay. So N and S both selected for varsity. No, because if N is selected for varsity, then R isn't. And if R isn't, then neither is S, because they're always together, so A is not going to work. B, O, and W. So if O is on varsity, then O could both be selected for varsity. Oh, O and W, yeah, we have an example of that right there. So B's got to be the correct answer. But yeah, Q and S can't be, because if Q is on varsity, then R isn't, and R and S would be together then. O and R, yeah, if O is on varsity, then N is on varsity, which means R isn't. And O and S, if O is on varsity, then N is on varsity. If N is on varsity, then R isn't. And if R isn't, then neither is S. So yeah, we have actually all of those represented in the example that we just gave. Kind of the same like line of reasoning was used to answer that question. But B is definitely possible. All right, cool. So yeah, that's it for that one.